Hi, I'm an old guy and I do maths, and today I want to introduce the idea of a thing called an identity matrix, the identity matrix. And I've got a couple of examples here, and I guess I should start off by talking about their characteristics. So these are square matrices, and they're characterized by a diagonal row of ones running from top left to bottom right. Everything else is zero. And what these things do is they have the effect of multiplying another matrix that looks like them by 1. And let's just see quickly how that works. So to multiply a matrix, what we will do is we take these numbers and we multiply them by these numbers. So it's 1 times 1 plus 0 times 3. Now 1 times 1 plus 0 times 3 is 1. 1 times 2 plus 0 times 4 is 2. 1 times 3 plus 0 times 1 plus 1 times 3 is 3. 0 times 2 plus 1 times 4 is 1. It's a sticky business. What can I say? Okay, so let's do something similar here. We're going to take this row of numbers and multiply them by this row of numbers, and we'll see what we get. So that's 1 times 1 plus 0 times these two numbers, so that's 1. 1 times 2 plus 0 times these two numbers, that's 2. 1 times 3 plus 0 times these two numbers, that's 3. You can see how this is going, but I'll continue. The number in the middle here will multiply these numbers through here. So 0 times 1 is 0, 1 times 4 is 4, 0 times 7 is 7. So we wind up with 4, 5, and 6 for that reason. Zeros times 1 and 4 is 0. 1 times 7 is 7. Zeros times 2 and 5 is 0. 1 times 8 is 8. And so forth, we get to 9. So that times that gives us that. Now, there's one other thing that I would like to say about this, and it has to do with a thing called an inverse matrix. Now, you may or may not be familiar with an inverse matrix. If you're just interested in the identity matrix, you can stop looking now. Those of you who know about an inverse matrix should know that the test for one is that if you multiply an inverse matrix by the matrix you started with, you wind up with the identity matrix. So I'm just going to go through that for those of you who are interested. So we have matrix A, 1, 2, 3, 4, and I've gone through the motions of working out the inverse of that manually. You can do this on a calculator, but I've done it manually. The discriminant is -2, so it's 1 over -2 times the rearranged form of this. 4 and 1 are in different positions, and 2 and 3 are negative. That gives me an inverse of -2, 1, 3 over 2, and -1/2. Now, when I take that, the inverse matrix here, which I've worked out, and I multiply it by this, what I get is the following. -2 times 1 plus 1 times 3, which gives me 1. -2 times 2 plus 1 times 4, which gives me 0. 3 over 2 times 1 times -1/2 times 3, which gives me 0. That's 1.5, and that's 1.5. One's positive, one's negative, so I wind up with 0. 3 over 2 times 2 minus 1/2 times 4 gives me 1. We have the identity matrix. And that proves that this is indeed the inverse of this. Okay, well, thank you very much for watching. I hope you found that useful and interesting. If you did, please like and subscribe, and I'll see you next time. Bye.